How to construct a tangent from a given point on an ellipse's perimeter. Okay, so I'm just going to put in an arbitrary point there. So let's just say we have a point, I put it in green here, on the ellipse's perimeter, and we want to construct a tangent from that point. Okay, so we have our ellipse here that we've already constructed using the concentric circles method in the previous video. The shorter line here is the minor axis and the longer line is the major axis. Okay, now an important thing about ellipses is you have to find the focal points, so we're going to find them now. So in order to find the focal points on an ellipse, what you do is you take your compass and you set it to half the major axis. Just going to do that here now. Okay, so I've set my compass to half the major axis. I place the point of the compass here at the top of the minor axis. You can do it from the bottom of the minor axis as well if you want. And I draw an arc that intersects the major axis, and I'm going to do the same on the other side. This arc intersects the minor axis. So they are the two focal points on the ellipse. Now, depending on, like I said before, the size of the minor and major axes, these focal points will be in slightly different places, but you always use the same method. So half the major axis. So I'm going to call that F1, and I'm going to call that F2. Okay, so I have my two focal points. Now, the next thing I have to do is I want to find the tangent to that point. So what I'm going to do is I'm going to join the point to F1 and F2. And once I've done that, what I'm going to have to do is I'm going to have to bisect this angle. Okay, so I'm going to bisect this angle, and we know how to do that. Simply bisect an angle, take your compass, and you take an arbitrary measurement. We don't know exactly what that measurement is, the length of that is to say. It doesn't really matter as long as it's the same on both sides. And then I place my compass here on that point, place my compass on that point, and where those two arcs intersect, this point and that point, I'll be able to bisect my angle. Okay, so this line here is a normal. I'm going to write that here. Which will sit perpendicular to the tangent to the ellipse here, which will go straight through that point. So we should have all the information that we need in order to find that tangent line. So now, using sliding set squares, what I'm going to do is whoops, broken pencil. No, it's okay. And then we have our tangent to the ellipse. Just to say that this point here is a point of contact, and it's always wise to label your points of contact, because the examiner will want to see that you understand what a point of contact is.